Parker Solar Probe is
3.8 million miles from the surface of the sun.
Yes, you heard that right. On December 26, 2024, NASA's Parker Solar Probe made history, flying closer to the sun than ever before, at just 3.8 million miles from the sun's surface. It's the closest humanity has ever ventured to our star. But 3.8 million miles might not sound close enough until you put it in perspective. If the distance between Earth and the sun were scaled down to 1 meter, Parker Solar Probe reached just 4 centimeters away from the sun. 4 centimeters. That's deep inside the corona, the sun's atmosphere. This is a giant leap for mankind, a testament to our unyielding curiosity and determination to reach for the stars. So join us as we dive deeper into this extraordinary mission. From the center of our solar system rages a powerful and relentless force. A wind forged in the heart of the sun races outward at speeds exceeding 1 million miles per hour, reaching the edge of interstellar space and touching everything in its path. This is the solar wind, a dynamic force that shapes our solar system. From sparking ethereal auroras on Earth to stripping atmospheres from planets, the solar wind carries with it the sun's touch, its energy, and its mysteries. This incredible phenomenon begins on the sun's surface in regions like dark, cool coronal holes and active zones bursting with magnetic power. These areas release streams of charged particles forming the solar wind. These streams carry the sun's magnetic field, stretching and spiraling as the sun rotates. This grand spiral, named for solar physicist Eugene Parker, is a cosmic signature of our star. It was Parker in 1958 who dared to theorize that the sun breathes this ever-flowing wind of particles, shaping the environment of the entire solar system. When this electric breeze blasts into lunar rocks, it sparks a cosmic alchemy. It can break atomic bonds, forging molecules of water. In 2020, NASA's SOFIA mission revealed a stunning discovery. Water created this way on the sunlit surface of the moon, an unexpected reservoir, born from solar particles and lunar dust. As the solar wind races outward, its first major encounter is Mercury. This small, scorched planet endures the full force of the solar wind, its thin magnetic field offering little protection. But here on Earth, we are shielded. Our powerful magnetosphere acts as a cosmic shield, deflecting most of the solar wind's fury. Yet even here, some particles slip through, colliding with atmospheric gases to paint the night sky with the shimmering colors of the auroras. But for all its power, the solar wind has long kept its deepest secrets hidden, until now. NASA's Parker Solar Probe, a marvel of human ingenuity, is venturing closer to the sun than ever before, diving straight into the heart of this celestial tempest. For centuries, humanity has looked to the sun, marveling at its brilliance and power. But what lies within its fiery depths? On December 14, 2021, the impossible became reality. Parker, flying through the sun's upper atmosphere, the corona, and sampling its particles and magnetic fields for the very first time in human history. This extraordinary feat is more than just a technical triumph. Parker's journey is unlocking answers to mysteries that have puzzled scientists for over 6 decades. Why is the corona, the sun's outer atmosphere, hundreds of times hotter than the sun's surface? How does the solar wind accelerate to supersonic speeds? What are the sources of the sun's high-energy particles? Equipped with 4 cutting-edge instrument suites, Parker is studying magnetic fields, plasma, and energetic particles, as well as imaging the solar wind. This data is not just academic, it has real-world implications. We live within the sun's atmosphere, and its behavior affects everything from satellite operations to power grids and astronaut safety. By tracing the flow of energy and studying the sun's impact on Earth, Parker's mission holds the key to understanding, and perhaps one day forecasting, space weather. The mission is named in honor of the late Dr. Eugene N. Parker, a visionary who revolutionized our understanding of the sun. In the 1950s, as a young professor at the University of Chicago, Parker developed the first mathematical theory predicting the solar wind, a constant stream of solar material that connects the sun to its surroundings. Today his legacy lives on in the spacecraft that bears his name, boldly venturing into the sun's fiery embrace to answer questions he first posed decades ago. In the early hours of August 12, 2018, at precisely 7:31 UTC, humanity's most daring mission to the sun began. From Cape Canaveral Air Force Station in Florida, a Delta IV Heavy rocket roared to life, carrying with it an extraordinary payload, the Parker Solar Probe. At launch, the spacecraft weighed just 1,510 pounds, roughly the size of a small car. But its mission was monumental, to venture closer to the sun than any spacecraft in history. This bold endeavor is collaborative brilliance of NASA's Goddard Space Flight Center and the Johns Hopkins University Applied Physics Laboratory. Propelled by the power of the Delta IV Heavy with an upper stage, Parker began its historic journey, overcoming immense challenges to explore a realm where no spacecraft had dared to go, the sun's atmosphere. A feat of engineering, science, and determination, this mission is humanity's first step toward truly touching the stars. Diving into the sun's atmosphere is no ordinary journey. The Parker Solar Probe was engineered to face the unimaginable, temperatures exceeding and the chaotic violence of coronal mass ejections. To survive this environment, the spacecraft required an unprecedented design. At the heart of its protection is a revolutionary 4.5-inch heat shield, crafted from carbon-carbon composite. This shield is not just a barrier, it's a lifesaver. While the sun-facing side endures temperatures of 2,500 degrees Fahrenheit, the instruments nestled behind it remain at a safe, room-like temperature of just 85 degrees Fahrenheit. The sun's intense photons deliver most of its heat, so engineers developed an ingenious solution, a white, luminous plasma spray coating. This reflective layer bounces away solar photons, keeping the probe's interior cooler and shielding its delicate instruments. There's another challenge: distance. It takes light 8 minutes to travel from the sun to Earth. With this delay, relying on real-time commands from mission control is impossible. The Parker Solar Probe had to be built with intelligence, a fault management autonomy that ensures it can think for itself. For instance, the probe is programmed to keep its shield precisely facing the sun at all times, even during sudden movements or unexpected changes in its environment. This autonomy allows the spacecraft to adapt, react, and protect itself as it plunges deeper into the sun's inferno. The Parker Solar Probe relies on the very source of its mission, sunlight. But here's the challenge: how do you use solar panels near a star that could destroy them with its heat? The probe's solar arrays must remain cool to function. This isn't an easy task when temperatures soar to extreme levels. The solution? A state-of-the-art liquid cooling system, carefully designed to regulate the temperature of the solar panels as they gather energy in one of the harshest environments imaginable. What makes this system even more remarkable is its adaptability. As the probe ventures closer to the sun, its solar panels are intentionally exposed to less sunlight, reducing the surface area while maintaining the same energy output. This ingenious design ensures the spacecraft always has the power it needs to complete its groundbreaking mission. The Parker Solar Probe is more than a spacecraft. It's a triumph of engineering, a masterpiece designed to endure the sun's fury and unlock the secrets of its burning heart.